Complex number syllabus we have done long back. Yes. Till the last class we did here, that is what is required for school examination on complex number, like up to properties of moduli. Properties of modulus you remember, mod z1 plus z2 equal to less than equal to mod z1 plus mod z2, mod of z1 z2 equal to mod z1 into mod z2. We worked on it also. One additional thing we have learned apart from board exam, that is cube roots of unity. Omega. We did it. If one root is omega, other root is omega square. Actually your entrance exam preparation, CBSE plus many things. One of the topic only so far we have covered, that is cube roots of unity, and I showed you one very simple application, factorization of a cube plus b cube. Properties of modulus we did a few sums, elementary level of sums. Polar form now excluded from CBSE syllabus, but for all competitive examination, polar form plays a very important role. You should learn it properly. Okay? So let us start. What is polar form? Let me explain what is polar coordinate first. Try to understand. What is a polar coordinate? Just a minute. What is a polar coordinate? Polar coordinate, like coordinate in 2 dimension. When you say coordinate of a point is p r theta, it is called polar coordinate. It means what? There is an initial line. This is called initial line. From there you have rotated by an angle theta. Okay? And this extreme point has coordinate p r theta, means from the pole, this O is called pole, and this is the radius vector. R equal to OP, this stands for radius vector. Hope all of you are ready with me. I am doing extremely slow rate. You do it with me, otherwise you will forget. This is called radius vector. Okay, so a point in polar coordinate has r theta form. Theta stands for initial line made by the segment with initial line, and r is the radius vector joining pole to the point. Actually all rotations will be with respect to this pole. O stands for pole here. Okay, but you are doing everything in 2-dimensional coordinate system only. Even you have drawn x axis, origin to this x axis. So this point must have a coordinate. Let coordinate of the point be pxy with respect to the coordinate axis. I am drawing y axis over there. Just additional axis I am drawing. Just to mention that the point which has polar coordinate r theta, it has coordinate x comma y also, and we have to find equivalent things. Like we want to compare now this Cartesian coordinate and the polar coordinate. If you want to convert Cartesian to polar or polar to Cartesian, then it is possible now. Okay? Sometimes if we express in terms of polar coordinate, equation looks very, good form. XY form may be very longer, but polar form will reduce calculation, equation, all these things. That's why it is essential. Polar to Cartesian, if you want to convert, you draw a perpendicular here. From P, you draw a perpendicular. Let PM be perpendicular on x-axis. PM is perpendicular on x-axis. Then what about this point? It is x. What about this point? It is y. So in this diagram, x is what? R cos theta, and y is what? You can see that y by r is sin theta, isn't it? So y is r sin theta, and this way we can convert polar r theta to Cartesian form xy. Okay. If you want to convert Cartesian to polar, then what to do? If we have r theta given, suppose polar coordinate, just let us solve one example. Polar coordinate given, polar coordinate of a point B 2,60 degree. Then its Cartesian coordinate will be what? Cartesian coordinate would be same point. It has Cartesian coordinate what? X equal to 2 cos 60, y equal to 2 sin 60. Okay. So this is nothing but root 3 and this is 1. So 2,60 is equivalent to what? This is equal to root 3, 1. Is that clear? Clear? Now, how do you convert Cartesian to polar? If Cartesian coordinate given, how do you get polar coordinate? You start with this equation. We know x equal to r cos theta and y equal to r sin theta. So just squaring and adding. What do you get? Squaring and adding. X square plus y square equal to r square. So r equal to under root x square plus y square. Isn't it? And how do you get theta? Just divide 2 by 1. Dividing 2 by 1, we have y by x equal to tan theta. So theta equal to tan inverse y by x. Clear? So can I convert xy to r theta now? If I know xy, then I can find r, I can find theta also. So xy can be changed to r theta by using this relation 1 and 2. Is that clear? Let us solve one example. Convert root 3 comma 3, this is xy, into polar form. How to convert this into polar form? We will write r first. To answer this, we write r. First we will write r. What is r over there? By this formula 1, r equal to under root x square plus y square root 3 square plus 3 square 3 plus 9, that is under root 12. So this is 2 root 3. Clear? We got r. How do we get theta? Just use formula 2. From 2 we will get theta equal to tan inverse y by x. Okay. This is tan inverse, what is y? This is x and this is y. So this will be 3 by root 3. What is its value? Tan of which angle is root 3? Tan 60 degree is root 3. So you have converted root 3 comma 3 to 2 root 3 comma pi by 3. Clear? Done? Now why you are going to introduce it in complex number, in complex plane? Complex plane is actually two-dimensional plane only. Since we are representing complex number, that imaginary part will be along y-axis, real part is along x-axis. There is no contradiction. So when you are saying the polar form of a complex number, then it is going to be of this form, that r is equal to, complex number is of the form, we are going to discuss polar form of z equal to x plus iy. Okay? So if we just assume that the complex number lies in first quadrant, imagine the complex number lies in first quadrant, x, y, this x, y lies in first quadrant, P is a point in the first quadrant, P, x, y. Okay? How to represent this in two-dimensional coordinate system, this complex number, let us see. That you know, representation you know, z equal to x plus y, but it will be in terms of r and theta now. This r is what? R we have learned by Pythagoras theorem, root over, it is basically mod z, no? And theta is what? Tan inverse y by x. Okay? So if we want to express now this x going to be what? X by r is cos theta. This implies x equal to r cos theta. Y by r equal to sin theta. Y equal to r sin theta. Clear? So what is z now? Z going to be what? So z going to be x plus iy. This is nothing but r into cos theta plus I sin theta. This is called polar form of complex number. Okay? Clear? It's all right? So polar form of z equal to x plus iy means it will be of the form r into cos theta plus I sin theta, where theta is known as argument or amplitude. And r stands for what? R is mod z. Finding r is not a problem for you. You are very good at this. But argument, you are good at argument also if the complex number lies in first quadrant. Problem arises if the complex number goes to second quadrant, third quadrant, or in fourth quadrant. How? Why? Don't memorize anything in this world. You learn it first. You are a student of mathematics, everything should be judged. Somebody has told you argument, if it lies in second quadrant, then pi minus theta, then please don't go for that. You need to know why. Just let me explain. This is first quadrant case, tan inverse y by x. If it lie in first quadrant, we will do this manner. Now if x less than 0 and y greater than 0, that is the complex number lies in second quadrant. Complex number lies in second quadrant. How to find its polar form? Just let us draw the diagram. P, this point has coordinate P dash, it is minus x comma y. Remember one thing, that argument of complex number will be greater than or equal to minus pi, less than or equal to pi. It will not exceed this interval. It has to be there. So now if I take this angle is theta or alpha, suppose I am taking this angle alpha, then this r remains the same, isn't it? X lies here, I mean minus x. If I say tan alpha equal to mod y by minus x or mod y by x, it will be appropriate. And r is what? Root over x square plus y square. But this alpha is not argument. Alpha in the complex plane or organ plane, this complex number makes some angle with x-axis, positive direction. That will be amplitude. So amplitude Z is going to be what? Theta. Theta is what? Total angle 180 degree? Pi minus alpha. Pi minus tan inverse. Hope the concept is clear. The argument of the complex number is pi minus tan inverse y by x if theta lies in second quadrant. Let's see what happens when theta lies in third quadrant. If x less than 0 and y less than 0, then what will happen? X less than 0, y less than 0 means P lies here, minus x minus y, draw a perpendicular on x-axis, join it from origin. Origin to P you have joined. This r is distance from origin is x square plus y square. That's true. But amplitude, if you want to say, it will be with positive direction of x-axis. If you say that, so amplitude is clearly this one, then I don't agree. Because this angle, it is more than pi. So we must not take this one amplitude. Instead, we are considering amplitude this manner. Okay? Now, like previous case, this angle is known. This be alpha. Let us write alpha and from there amplitude. So this portion is called amplitude. So how to write amplitude this time now? Because this angle is alpha, so minus pi, this is minus pi, no? From here to here, if you consider minus pi, we want this angle. So this angle means total angle pi, from pi you subtract alpha. So it is going to be alpha minus pi. But what is alpha here? How do I get alpha here? This is minus x, this is minus y. Tan alpha, this is acute, no? You cannot take negative sign over there. So you take this part minus y by minus x. Y by x. So alpha is what? tan inverse mod y by x. So this is going to be tan inverse y by x minus pi. Alright, this is the amplitude. So if it lies in third quadrant, the complex number, then it will be tan inverse mod y by x minus pi. What is its value in the second quadrant? Second quadrant, pi minus tan inverse y by x. Third quadrant, just opposite, tan inverse y by x minus pi. Remember this thing. Now let us go for fourth quadrant. Try to prove fourth quadrant how it is minus tan inverse y by x. Then I will tell you the steps. That will help you a lot to remember all these things in a frame. You just try to get the amplitude when the complex number lies in fourth quadrant. Z lies in fourth quadrant. X, Y. The complex number lies here. The coordinate, if you draw a perpendicular here, this point, both x and, no, x positive, y negative. If you join origin to this point, then argument is going to be this angle. Clear? This theta. This is x and this is minus y. So tan theta will be what? Tan theta will be again mod of minus this acute angle you always find by using mod sign. So tan theta is just y by x. So theta is what? Tan inverse mod y by x. Therefore, amp z in this case, or argument z, will be what? Argument z going to be equal to minus theta, that is minus tan inverse mod y by x. This is argument z if complex number lies in fourth quadrant. So let us summarize the observation above. What will be steps for finding amplitude of the complex number? Z equal to x plus iy. Whatever, x sign, y sign, we don't care. We will remember the rule I am going to discuss, which you have already proved. So for z equal to x plus iy, for z equal to x plus y iy, step 1. What is the step 1? Find theta equal to tan inverse y by x. Isn't it? Find this thing, theta equal to tan inverse mod y by x. Step 2. Check in which quadrant z equal to x plus iy lies. Then step 3. Step 3 will decide. Step 2 just check in which quadrant it lies. Step 3 we have several cases. How many cases? 4 cases. Case 1 is what? If z lies in first quadrant, then amp z is what? That's what it got there. amp z equal to tan inverse y by x. Mod irrespective, you put or you don't put, doesn't matter. Then case 2, if z lies in second quadrant, then amp z is what? Pi minus theta. Theta always you find by this method. Without hesitation, in the very first step, find theta by using this relation. Clear? Then you are remembering these cases only. Derivation you don't have to do in exam. Just apply it. Step 3. Step 3 no, just case 3, better to say. This is case 1, case 2, and this is case 3. If z lies in third quadrant, then amp z is what? Theta minus pi. And number 4, if z lies in fourth quadrant, then amp z equal to minus theta. Clear? So what we are going to do, we will apply the concept in solving simple sums first. Whatever you learn, you should learn properly, no? Then we will deal some Lucas problem. Let us take one example to find the few examples I am writing. You can write the answer only. Find the amplitude. Number 1 I am writing √3 minus I. Number 2 it is minus I plus 1 minus 3 minus 3I, and number 4 √3I plus 3. Let us write the answer only. By the formula, by the method we have learned, with this formula you can get it quickly for amplitude. See how to find. For this one, always you write the equivalent xy. It is √3 minus 1, so x positive, y negative. Which quadrant it goes? It goes to fourth quadrant. Agree? You find theta. Theta is what? Tan inverse mod y by x. Always mod y by x. Whatever they have given, you find this part positive. What is that? Tan inverse 1 by √3. That is pi by 6. It lies in fourth quadrant. So amp z answer you will write here. This is minus pi by 6. Clear? This is your conclusion. This is the fourth case here, no? So now it is mechanical. Understanding part was different. But when you are solving MCQ, you must be very smart. You just write the answer from this. What happened to this case? In which quadrant it lies? Minus 1, 1. It goes to second quadrant. What is the first step? We'll find tan inverse mod y by x. It is tan inverse 1 pi by 4. In which quadrant complex number lies? In second quadrant. So its amp z will be pi minus pi by 4. Is that clear? And what about the second case? When you are going to find? Here theta is tan inverse y by x. tan inverse 1 pi by 4, and the complex number lies third quadrant. So amp z going to be pi by 4 minus pi minus 3 pi by 4. Hope all of you have understood and you are doing it with me. For this one, theta is what? Tan inverse, here x is 3 and y root 3. The number is 3 comma root 3. We need not put mod here, both are positive. Tan inverse, which angle has tan theta 1 by root 3? Pi by 6. So amp z will be what? It lies in first quadrant. Amp z will remain the same. Clear? So this way we can write the amplitude of complex number easily. But I want to show you few more sums on it. Like suppose a problem arises this manner. What is modulus and amplitude of 1 plus I by 1 minus I? Okay, we can use the theorem. Theorem I am coming later. First, let us learn how to get it by just converting into x plus I y form. How can I convert in x plus I y form? We need to multiply inner and rear by conjugate complex number. What is conjugate of this? So this is 1 plus I whole square and this will be 1 minus I square. So 1 plus I square 2I square is minus 1. So it is I. Now there is a problem start. This has a equal to what? I mean x equal to what? 0, y is 1. So this point lies where? This point lies on y axis. So what will be the amplitude z here? Amp z equal to pi by 2. Sure. It is pi minus alpha. If you say that, I can observe it is pi by 2. Why should I go by that formula? No problem. You do that. Secondly, that alpha is pi by 2. Total angle is pi. Pi minus pi by 2 will give us pi only. So amp I is equal to pi by 2. Clear? So this way you can convert to find the amp z. Let us solve one NCERT exemplar problem. It is minus 16 by, you do it before I do, minus 16 by 1 plus I root 3, you have to find its amplitude. Amplitude of this complex number. Do it yourself. So this one amplitude we can get by the concept you have already learned. Theta equal to tan inverse mod y by x. We will always find 4 root 3 minus 4 tan inverse minus root 3. This is what? Tan inverse root 3 is how much? This is pi by 3. theta equal to pi by 3. Clear? So amp z is pi by 3. Now suppose they have asked you to express this one in polar form. We need amp z. Amp z is correct or wrong? I wrote, but you had no objection. It is minus 4 plus 4 root 3 lies in this quadrant. So amp z is incorrect. It will be pi minus pi by 3, that is 2 pi by 3. Clear? And we need to find modulus. Mod z is what? This property we have learned in the last class. Modulus of numerator by modulus of denominator. Remember it? Mod z1 by z2 equal to mod z1 by mod z2. So this will be 16 by under root 1 plus 3. 16 by root 4, that is 8. So you got modulus, you got amplitude. So this complex number will be equal to what? Therefore, minus 16 by 1 plus I root 3 is going to be equal to mod z, r into, r is what? R is mod z, 8 into cos 2 pi by 3 I sin 2 pi by 3. Clear? So after getting amplitude, we are writing polar form is this. We have learned just now, polar form is what? X plus Iy equal to r into cos theta plus I sin theta. Theta stands for amplitude. Here theta I have used for different purpose. Remember, when you are writing, you have to put the amplitude. If you don't put amplitude, it will be wrong. This is not polar form then. Even if you get negative sign, you keep negative only over there. Do not try to change that sign minus theta is minus sin theta. Don't. If they ask you to write polar form, then you preserve the sign over there, sign of the angle. Clear? Just I am asking one sum. Let's see what is your answer. Find the polar form of this complex number. It is, say I am asking cos 120 minus I sin 120 expressed in polar form. This is the question given. Expressed in polar form. It is not in polar form. Never. We first do convert this one in x plus iy form. Don't keep cos 120 sin 120. It will confuse you. This part is what? Minus half minus I root 3 by 2. So minus 1 minus I minus 1 by 2. Okay, it is there only. Isn't it? So in which quadrant this complex number lies? This complex number lies in third quadrant here. Okay. So this is equivalent to, in terms of coordinate, minus half minus root 3 by 2. Isn't it? X. This is y. So in this quadrant it will be theta minus pi. But what is theta here? Let us find theta. Theta we have defined forever this form. Mod y by x. There is tan inverse mod of minus root 3 by 2 minus half. Tan inverse mod of root 3. It is pi by 3. Clear? So amp z will be what? As it lies in third quadrant, it will be theta minus pi. So answer is minus 2 pi by 3. Clear? So the value is minus 2 pi by 3. Now I am expressing polar form. See how I am expressing. Therefore, what sum they have given, I am working on it only. Then you will remember better. By seeing it, never think that this is given in polar form. This is R. R is what? R means? Mod Z. Mod Z is root over 1 by 4, 3 by 4. That is 1. So 1 into cos theta plus I sin theta. This is the polar form of the complex number. Okay? You will say that if I keep minus sign, then it is wrong. No, it is not clear from there. Amplitude minus 2 pi by 3, it is not clear. From there he is saying that amplitude is 2 pi by 3. Wrong. It is minus 2 pi by 3. 2 pi by 3 and minus 2 pi by 3 will have a difference. Clear? Understood? How to express, how to get the polar form, you understand. Let us do one tricky sum from there to get the polar form of this complex number. Express sin pi by 5 plus I into 1 minus cos pi by 5. What is there in your syllabus, in school syllabus?
Maybe
Trigonometry?
Trigonometry and complex number.
So, why are you, trying to say that you have to practice, Practice you will do. You have to do some advanced topic every day and then you revise.
No, sir.
So, when it is over, then you go for this. Let me complete this part. I'll do 1 or 2 locus problem, then it will be done. Okay? Rizendo, are you there? Hello? Rizendo, are you there? Oh, I am silent here. Wait a minute. Rizendo, can you hear me? Rizendo typing. His microphone not working probably. हाँ sir. Okay, chalo. So how to find the amplitude, polar form of this complex number? Let's see. How to find this? How to find the polar form of this complex number? What is z here? It is x comma y. What is xy over there? Sin pi by 5, 1 minus cos pi by 5. We don't know in which quadrant it lies, isn't it? In which quadrant it lies, we know or we don't know? Of course we know. Sin pi by 6 means pi by 5 means what? Sin 36. It is acute. Cos pi by 5 acute. And cos pi by 5 never exceed 1. So it lies in first quadrant only. Am I correct? But finding R is very difficult here. What is R here? This question is important for school based exam also. Sin pi by 5 whole square plus 1 minus cos pi by 5 whole square. Sin square theta cos square theta is 1. This plus 1. So you take 2 common, 1 minus cos pi by 5. So this is what? Under root 2 into 2 sine square pi by 10 by using some multiple angle formula. 1 minus cos theta is 2 sine square theta by 2. Use that only. Okay? You forgot? You don't remember? 1 minus cos theta. Theta is like pi by 5, no? What's the formula for it? Yes. So 1 minus 1 minus cos pi by 5 is 2 sine square pi by 10. Yes. I'll explain. Wait, let me finish this session. I'll explain in details. Okay? So it's 2 sine square pi by 10. 1 minus, I have used this formula. 1 minus cos theta is 2 sine square theta by 2. I have used that only. So 2 sine pi by 10. So R we got. Now what is amplitude? As it lies in first quadrant, don't take trouble. It is tan inverse. What? 1 minus cos pi by 5 by sine pi by 5. Again I remind you that some multiple angle formula, 1 minus cos pi by 5 is what? 2 sine square pi by 10 to sine pi by 10 cos pi by 10. Isn't it? So this is tan inverse tan pi by 10. Answer is pi by 10. Okay? See how interesting the answer is now? You got R, this 2 sine pi by 10, and the amplitude also you got pi by 10. So what will be the representation of this complex number? Let me write. This is R. R is what? 2 sine pi by 10 cos theta plus I sine theta. It's obvious. Now you understand? Just one thing I'll not do, because it is almost a long session. I'll not do many sums on Lucas problem, but Lucas problem we started in the last session. We'll continue in the forthcoming session also. Here, with the help of argument, how to get the locus of a point, that you try to know. Lucas problem means that x, y wala problem. With the help of argument, how to get it. Clear? Let us take one simple problem. Just write, find the locus of the point. Find the locus of the point in complex plane satisfying the relation argument z minus 1 by z plus 1 equal to pi by 4. Next session I will be discussing mainly Lucas problem and De Moivre's theorem. Very useful theorem in complex number for JEE Main and Advanced. Okay? This class just I give you the introduction. How to find Lucas problem here. Lucas means we have to get an equation containing x and y. How to start? To answer this kind of question, you start this manner. Let z equal to x plus iy, and then simplify it. This is going to be what? X plus iy minus 1 plus 1, x minus 1 plus iy plus iy. Clear? So now you write x plus 1 plus iy. I mean, rationalize it. Don't say rationalization, it's a wrong statement. You agreed. I wanted to verify you remember or not. This is not rationalization. This is just removing I from denominator. That's why multiplying by conjugate complex. X minus 1 plus iy, x plus 1 minus iy. Just multiply. Denominator has become x plus 1 square minus I square y square plus y square. Numerator, if you multiply x square minus 1 minus I square y square is y square. I into, just do this thing, xy plus y minus xy plus y. This to get cancelled. So what have you got here? Z minus 1 by z plus 1 equal to this, or z minus 1 by z plus 1 equal to x square plus y square minus 1 by, my aim is to express in x plus iy form. Clear? This is of the form what? This is of the form a plus ib. What is a over there? This divided by, and b is what? Clear? So once you get this thing, they ask you to take this argument z minus 1 by z plus 1 equal to pi by 4. That is tan inverse b by a pi by 4. So b by a is tan pi by 4. This is 1. B equal to a. B equal to a means 2y by clear? So this implies this one is of the form this. Just little manipulation. This is a circle, which is a circle. Okay, why this is a circle? Circle equation is of this form: x minus alpha whole square y minus beta whole square equal to r square. This is equation of circle. We got that form. That's why it is circle, real circle. Clear? Understood? So wait for the next session. We will discuss more problems on this topic.